Hey guys, 3 minutes passed already. Since we have this small intro in the beginning, it will be a nice opportunity for more people to join because I think more and more are coming. So let's start. Hello everyone, welcome to Munich.net Meetup. This is another of our online meetups, online events, this time with Florian Rappl. We sort of got used to have these online events, but personally, I really hope we will end with this situation soon enough. I hope it will not be for long. Yeah, I miss the pizza and the beers. Yeah, and of course the interaction with everyone. So, as I said, Florian is today with us. He will tell us a lot of things, some of those about an interesting development in the Piral framework, where you can build Blazor pillets. For those of you who are not going to get in any details, for those of you that don't know what Piral is a framework for building high modular applications, and Pilot is a smaller chunk, let's say. I will show you. Just give me a minute. And this is this micro app one, for example. This on the left side is a pillet, could be potentially. For the correct pronunciation, Florian is here to correct me if I'm wrong anywhere. So there is no reason to keep you waiting. Just two more things. First of all, we are recording this session. So if any one of you rejects that idea and doesn't want to go public, we plan to publish it in YouTube. Just send me a message and we will arrange everything. Not to worry about that. And the second thing is about questions. So we will have some time at the end for questions, of course, but how we'll do it? One way is to send something in the chat. Me and Florian, we will monitor chat, and if I will pass to Florian any question you write there. Or you can, there is a nice, cool feature, raise your hand. I will try to monitor who raises your hand, his or her hand, in order to chat with Florian live. Yeah, nothing else from me. Florian, please, I will stop sharing my screen. I think you can't share your screen without me stopping first. I just did. And I will stop my camera just to save some bandwidth, and I think we are ready.
Thanks, George, for a nice introduction. Yeah, topic today, microfrontends with Blazor. Yesterday, Blazor went to general availability. Version is 3.2.0, I guess. That marks for Microsoft quite a big step because, yeah, beforehand, they already brought the server-side Blazor into, let's say, general availability, and now it's also WebAssembly that follows. So I guess quite some exciting times. Let me also make this small. Yeah. Cool. So for those who don't know me, hi, I'm Florian. I'm a solution architect at a company called Pirrot. There I'm practicing architecture in the following spaces: IoT and embedded computing, digital transformation, and in particular creation of distributed web applications. These days I'm mostly active on the front end, but actually I'm always, as a solution architect, having the full platform in my mind. I'm also doing some open source work. So in that regard, Microsoft also, since I think I need to now look back, I guess 8 years or something like that, awards me the Microsoft MVP. It's now called MVP for development tools. And my primary areas in open source work are in .NET and JavaScript/frontend. I'm also writing some articles for online blogs and magazines, so whenever I have the time, I do that. Before jumping in with that motivational example that I have here, I want to mention two things which are my main objectives for the talk today. Yes, the topic is microfrontends with Blazor, and here I have two, let's say, goals set. The first goal is that I can actually share with you where we currently are in the development of larger scale Blazor applications, what you can do actually to distribute the workload in your team, and also to build large scale Blazor applications, not necessarily using microfrontends, but maybe using classical patterns that you're aware of. So where are we here, and what can we do to, I don't know, improve performance? And then, of course, also going here into the microfrontend direction, and what's the current state here. Now, the second objective is then to actually motivate you to contribute also to the development in some areas that you will see, where I would say there's still a gap between what Blazor offers right now and what either, of course, needs to be done by, let's say, efforts from the Blazor team, or by community in form of libraries, frameworks, and whatnot, to actually make this really convenient and really easy to tackle for everyone. And I hope that these 2 points I can convey to you, and that would have been the dream for me to, well, achieve that in this talk. But without further ado, let's jump right into my motivational example. So regarding microfrontends as a whole, what you can see here on the screen, I hope it's shared properly. Otherwise, George, always just interrupt if something is going wrong. And by the way, I agree, meeting in person would definitely be after that time a cool thing to have, is what we would call microservice backend architecture. Now, how these services communicate with each other, either directly or, we are maybe some kind of broker, service mesh or whatever, that doesn't really matter. But the thing is, we split up our backend into different services. Of course, that's not always the solution. We know that, and this kind of architecture has become, let's say, kind of an anti-pattern as well. It's used way too often, but nevertheless, it's like what you could call a state-of-the-art architecture, and it's done very often. And of course, it's done very often because it offers some clear benefits. So we are scoping here around business capabilities, which means we can have dedicated teams that really know their stuff and only know this one stuff. It can be actually autonomous teams, which then have their own development and deployment lifecycle, which is great because, well, you don't need to align here, and you can just go ahead, bring your own domain-specific service to production, and have already a value add without impacting all the other systems. Usually these systems should be loosely coupled. That's why I mentioned different ways of communication, and also they are technology independent because, well, they may run on different machines anyway. And so the only thing that actually makes them communicate is the way of communication. And these are pretty much technology independent. Now, if we now look at how it's actually exposed to the user, we usually have a single front-end solution. And now we could, of course, say that's for good reason, of course. We have here a monolithic architecture that comes with some advantages too. So for instance, we got one user experience that's delivered. And that's quite important for a front end because you don't want that page A looks, well, I don't know, like from one company, and page B looks like from another company, even though it's the same application and coming from the same company. So if one button is green and the other time it's red, it may be an indicator that something was not really aligned. Now, in order to get that monolithic architecture really off the ground, you usually define one central team. I mean, there may be satellite teams too, but usually it's one central team, and you have then these larger deployment releases. So things that you usually wanted to avoid when you actually went, for instance, for microservices on your backend. And if we ask the question then, well, how are other large-scale front-end applications developed that we know of, for instance, here the Azure portal in an older version, then you immediately think of how can they do it? Do they have one big team, and is every feature then going over that team? And partially, of course, in case of the Azure dashboard, that's certainly true to historic context. But they also already modularize their front end, and you can actually independently deploy their certain features. Another thing from Microsoft where you also see that, well, a modularization of the front end makes sense and already has a value add potentially is Azure DevOps. In Azure DevOps, you have certain plates that come with extensibility out of the box. For instance, also the test plans you will only get, and I mean get means you also just get the code for it when you are actually from your subscription allowed to have the test plans. You can also have extensions that either you write or that third-party vendors have written, or of course official extensions that come from Microsoft, and that also just embed in this application that runs in your browser. So it is an application that out of the box comes with some extensibility. And that's quite nice because these extensions, again, can be developed by independent developers or independent teams. Of course, at this point, one can say, well, it's Microsoft, and Microsoft has a huge engineering stack and a lot of resources here. But I mean, if we look at, let's say, German-based companies like here, as an example, Zeiss, they also have a customer portal that follows exactly this kind of principles, right? So all of their functionalities that you also see here on the screen, they are individual modules which are either rolled out towards the end user when you visit the site or not, right? Depending on what kind of user you are, you can now access certain features. And the next step, of course, is that not only there are these modules which come in on demand and give already a lot of benefits, not only independent teams, but great personalization, etc., but these different modules, they may even be created using different technologies. Usually, the best approach is just to choose a single technology, because then everyone in all the teams can maintain this. Well, at least ideally. But maybe there's a special kind of module, and let's just pick this one screen where we say, oh, we already had the code because we already had, I don't know, a WPF application that already had all the business logic. So we already had that in C#. So why not use something like Blazor for this? And so what we can do is we can just say we have a certain kind of component or a whole page or a whole spectrum of components, and these components are written in a certain kind of way, for instance, using Blazor. And that's actually like the gist of this talk, that you can actually mix these things together. And why I think Blazor is an attractive target for microfrontends is twofold. The first is, by default, the startup of Blazor WebAssembly is rather slow. I mean, that's due to two things. First of all, WebAssembly, I mean, it needs to prepare a lot of things. Okay. Second, getting C# really small, also not so easy. I think the current minimum size of a Blazor app is like 1.6 megabytes. And people start complaining about, I don't know, React if you ship 100 kilobytes. So there is definitely, let's say, a gap here. But if the whole application starts with the speed of, let's say, React, and then your individual parts, like here, this widget, come a little bit later, I mean, that's totally acceptable. Of course, depending on what that widget does. If it only transports, I don't know, static information, then I don't think that Blazor is the right choice. But if you get here some really dynamic data where the migration from your C# code or whatever you had to a different technology would have been a lot of time, and this allows you now to share a lot of your code, then it makes sense, of course. Okay, so let's talk a bit about this microfrontend architecture, what we've seen. And then let's dive into exclusively Blazor and C# and what we can do here. Now, historically, microfrontend architecture is like, let's say, an extension of the backend. So if we now have a simplified view on the backend where we say, oh, we now have these, let's say, 4 services here, then ideally you can say each service gets their own kind of front end. And we could, of course, now say each of their front ends has come with their own website. That's not really a good user experience, of course, right? Because you get now 4 URLs and how to do that. Of course, there could be a link on frontend A that leads to frontend B, and then there's a link that goes to frontend C. And that's, by the way, already a valid microfrontend pattern. And that's a pattern where you don't need any additional resources other than, you know, running an additional set of web servers, or instead of exposing a JSON-based or I don't know, XML-based API from these services, you just expose some rendering capability and you render HTML. Now, this puristic view is almost never true because, again, you don't want to have links. You actually want that front-end B is maybe a part of front-end A, and maybe they are as a whole a part of front-end C, but still they can be developed independently. And so a lot of patterns emerged from server-side composition to client-side composition to, let's say, different variations. But in a nutshell, that's the idea here, that you actually develop independently these front-end pieces, and then they somehow magically come together. And that magically already should ring some alarm bells, because that means a lot of effort needs to be spent on actually being able to debug this distributed system, to actually view it locally, to actually do something with it, and not just to see it there sitting maybe in a production environment and then realizing that it doesn't just work together. So challenges, as we know from microservices, they come now to the front-end business pattern. Which is why we think there is also for a front end kind of a desired solution. So even more than for a back end, where you can still argue you want to have this distribution, for the front end, we still think there may be a good intersection between what we would have in form of a monolith, or what we have seen there as advantages, and also what we get from, a decoupling as with microservices. And this desired solution is where we should be after. So let's see what happens if we bring this together, and we call this then a modular distributed web application. Still, we can coin it microfrontend, but it's a very special corner of a microfrontend. And we are basing this on the following aspects. First of all, as with microservices, all the business capabilities, they should be just called, let's say, modules, or microfrontends, whatever you wish to call them, and they can be developed independently. So they are their own modules, and that's fine. So you got your whole thing about, I don't know, creating a service ticket or showing software downloads, or I don't know what, a contact form. So that's your business domain, and this is what you would create as a microfrontend. You don't want to have that always shipped, not even if the end user can take it. So you want to have a loose coupling with dynamic loading capabilities. This will be really interesting now in case of Blazor, as we will see, because lazy loading is not something that is out of the box possible with Blazor. There are ways around it, and I hope to show you how that's possible. You still want to have a shared architecture foundation, because looking at one microphone and look at in the other, at least some shared foundation should be there. And I mean, there can be something like, for instance, accessing the current user. It can also mean things like a common system for translations. You don't want to duplicate certain things in your system because, I mean, they really should spread. But other things you never want to, let's say, share or, use from other microfrontends. And this, of course, is what I would call architecture, and this should really be one common line across all your microfrontends. One thing that certainly should be shared is UI and UX, so that towards the end user, the solution always appears as one. And that's quite important for, I think, because at the end, I mean, you don't want that your development efforts and how many teams you have is really shining through to the end user. You just want to say, that's my application that gives you the following value, and that's why you use that application. You don't want to say to the end user, you use my application because I put more manpower into it than my competitors. That's definitely the wrong approach. So UI and UX is something very important, and something that you should, in whatever form, share. And sharing here can also just mean, that you have a design document that everyone needs to follow. It doesn't mean you have a technical component that's shared. But of course, there are now different ways of sharing, and depending on your solution, you should think about what makes sense here. And again, as one benefit, you should be able to develop these business capabilities in independent teams, and even better, you should be able to deploy independently too. So that, in the end, gives you something that's really distributed. Cool. So what would we do now? we seeing this picture where each of the front ends essentially was their own application. Let's modify this and let's change it to what we now envision. And as you can see, the application symbol is now gone, and what we got are these boxes. So these are just now modules. They are delivered in form of, let's say, packages. And what you get is, let's say, a round of a surrounding box. And this surrounding box is the so-called application shell, or in short, app shell. It brings core and common capabilities. It also brings some shared libraries if you want to have some. It also brings maybe something like a pattern library if you want to have your style guide or your UI UX manifested already in code that can be used. Always with the shared libraries, there comes a responsibility. So my recommendation would be to use just the least amount of shared libraries. If all your modules, for instance, would use Blazor, then of course Blazor is from the core set a great shared libraries. Comes with some problems, but we tackle these too. And otherwise, if you, for instance, have React in the majority of your modules, share that, because it's just otherwise some payload that is unnecessary. And if you do that, you can come to a very well established state that brings a great UX also from the loading perspective and makes your teams really agile in terms of development. And this is like the quintessence here. So there is no free lunch, there are always trade-offs, and you just need to think what's important for my application, and then you make the right choices there. All right, now looking at the evolution of these web applications, and just as a recap here, we started years ago with just a single system, front and back end was just one. When we hit an endpoint, HTML was returned. I mean, that was a great world actually, and it worked. And then people said, well, I want to reuse my API for some reason, but maybe I want to build really a fully dynamic front-end experience. And these single pages became really popular, so there was the split. And then the next step was, of course, to say, oh, well, why do we have one backend? We actually want to isolate certain functionalities. We maybe want to then sit them behind a gateway and have an orchestrator behind it and a reverse proxy. And suddenly, all the stack builds up again. This may not apply to your problem because this is just a way that the industry is going, but it doesn't solve all problems again. And if you can stick with the monolith, nothing better than that, right? That's just a dream. And now we have microfrontends, which means it's another layer. And you can compose this picture as you want to, right? So you can have still your backend in one system, but you put microfrontends on top of it. There are reasons for doing that, but a pattern that we usually see is that the microfrontends are really lived as they are displayed here on the right-hand side, that you already have a backend that's essentially distributed, and now the front end just follows. All right. Now, I already mentioned there are multiple implementation patterns. I don't want to bore you with that. Just for the introductory part, conclude with this. You have, for instance, one pattern that essentially uses a reverse proxy to then bring together renderings from several servers. So in this example that we see here, there's a fragment from server 2 that's inserted in server 1, potentially via something like edge side includes, or even the older server side includes, and then sends it to the end user. Benefit, of course, it's server side rendered. So for the end user, very fast. That makes a lot of sense, for instance, on e-commerce sites. And then we have the more dynamic patterns that are client-side composition, where the server sends back some HTML with a loading JavaScript. That's the application shell. And then the application shell starts to load other fragments from maybe other servers, or maybe the same server, but again, other fragments, and stitches them together on the client side. That makes a lot of sense for tool-based applications, like, for instance, these portals. It's great. And in this talk, we'll focus more on the second side, even though it's a variation of this pattern. But if you want to know more about a couple of these patterns, I introduced you the link. And if we publish this to YouTube, I will, in the comments section, also place a lot more links, all from the slide deck here. Now, finally, and we are just 27 minutes in. Okay, we was an introductory, but we are coming to Blazor, and I have a lot of code prepared, so let's not waste time. Let's start simple. Well, we can already do that. Just use, for instance, NuGet packages or standard libraries. So NuGet here is just an example how you distribute your library. You can do that however you want to. But the idea is that I have my application shell written now as a Blazor WebAssembly application. And it also comes, as we've seen, with maybe some used libraries and maybe some design library already in there. And now I just bring in libraries like I just consume library A, maybe a library B, library C, library D. These are all just, you know, my microfrontends now, only in terms of these libraries. And you may have used this pattern already because that was possible. I mean, pretty much, I guess, always with .NET, but already in ASP.NET MVC, it was used quite a lot. And there are, of course, variations of this, variations where even the server dynamically consumes these libraries and things like that. But that's possible here too. There are some advantages and disadvantages for this. The big advantages are it just stays in the flow. You start with Blazor, you end with Blazor or C#. It's just C# all the way. Also, you just have a single build for this. I mean, sure, all your libraries are built from different, if you distribute them via NuGet, are built on different pipelines maybe. But then in the end, to publish, you just have one publish step. And you need that with Blazor because it does tree shaking, and otherwise you cannot dynamically do it so easily. I mean, we'll see that it is actually possible, but yeah, more to that later. So we require the recompilation. There are also two more things. The cross-framework support is somehow limited, at least out of the box. So if we are already in a yeah, let's say application that is React, how do we now consume these React components? How do we consume components from Angular? Well, there is no direct path. We will see, you can do it, but at least directly it's not given. Also, there are other things like we need a full evaluation before starting. What does that mean? Well, when our Blazor application starts, it first loads all the assemblies that have been developed, which means the more libraries we get in this, the more microfrontends we have, the longer the startup will take. And that's actually not very scalable, right? Because you develop a new feature, new feature, new feature, that's more and more libraries, that's more and more things to download initially, and more wait time for the end user. And actually you want to stay with the same time to the end user and just offer more features. That's, in this scenario, out of the box, again, not so easily possible. And so let's start with the first demo. I have a lot of these demos, so let's get started. Blazor distributed. All right. First, show how that demo behaves. All these demos are, let's say, graphically not so interesting. It's mostly the standard template. But of course, what happens under the hood is then the interesting factor. And yeah, let's just first look how out of the box this thing is displayed. And then let's have a brief look at the code. And we can always use also these waiting times for questions. So George, you can monitor the chat and also throw in questions when we have such idle times.
Sure, of course, I'm on it. And yeah, please guys, feel free. If you have anything, just send something to the chat and I will pass it to Florian.
Cool. So again, standard application, I didn't change the counter here or the fetch data, but here we have comp A. And that one has just a single, on the screen, a single text. This Blazor component is defined in the Blazor lib_a package. Okay, well, what does that mean? Actually, I'll make it a little bit larger, 170. I hope you can see that well. And for that to investigate, let's look at the startup. And let's also make it 170 here, it's 161. So here I do not much. I have a Blazor sample here, and I have two libraries. Again, they're not for this demo, not transported via NuGet, but of course you can consume them for whatever you want to. Here, just make a project reference and it works. And these are just standard Blazor component libraries, nothing more. It's just how they look. And all I write here is add library. That's not, if you know Blazor, you know that that's not a standard command. We will look at what that does in a second. But for the moment, just see that these pages, we only have counter, fetch data, and the index. There is no notion here of this component A that we've seen. So we can have a look at the router. And we realize that it also uses additional assemblies. That's how you teach the router to also look in other assemblies for the markers, and it uses a special kind of attribute to see what routes are defined. Are there routes defined for the component, and what are these routes? Now we're going into this collector, and that's the helper I used here that actually uses the add or exposes this add library. And you see that's very simple code here. So and it should only give you the idea, right? And of course you can say that I don't use, let's say, the best patterns, but to convey the idea, I guess that's fine. Now what we're doing here is we are transporting a type in there, and that type should already be defined in some assembly. So we make it easy to, let's say, retrieve the libraries. And with that, we just add it to our libraries, to our assemblies. These assemblies are then used in the router. And then we also have the capability of introducing other special things, like, for instance, special menu items. And what we do here is we look for, by convention in this case, for all the types that actually are named nav item. So here, for instance, I have a nav item, and that just says, okay, I bring another nav link, and this navigation link actually goes to comp A. And that's about it. Comp A are defined here. And as we've seen, there is suddenly a thing in the menu, and there is also this page being available. And I can go even a step further and do the same thing. I can also go and say, oh, let's also use component B. That's defined now in libb. And if I start it again, so let's say I would recompile it on my server and republish it. Then, and I didn't do any other code change, right? Let's see if the zoom is preserved. I guess not. Oh, it seems to be preserved. That's great. I now also have comp B, and that thing also just works. And so you can define via, of course, a better mechanism or more extensible than I did here, entry points, like for instance your navigation, and then you can extend these points and you can bring whatever components you want to, and the problem is essentially solved at this point in time. Now one problem is solved. We already heard this application will now grow because you add more and more assemblies that need to be loaded, and that of course is not very good. All right, so that was the first demo. By the way, I will also publish all the code on my GitHub repository or my GitHub account. So, and the link will be shared too. So don't worry about that. And you can have a look how these fragments are then put in there. All right, so that was distributed Blazor. Works already, as you know, but comes also already also with these problems. And if you remember the start, we wanted to improve, for instance, the startup of Blazor. We've seen loading, and even there, I mean, the DLLs are loaded from a local machine. It took quite some time, and it's always like between 2 and 4 seconds, maybe faster on your machine. But again, it's certainly something you want to improve, and maybe Blazor is not your full application, but just a fragment of it. How do we do that? And that's where the second approach comes in. You can combine it with JavaScript, right? At the end, I mean, we don't see that, but all the Blazor experience is only possible via JavaScript. I mean, yes, MSIL is now interpreted via WebAssembly, and that's great. So they introduced a WebAssembly layer that can read MSIL code. But how to combine it with the document object model, how to, I don't know, make a fetch call, how to read the current location path or change this, that's all JavaScript. And actually there's a whole lot of JavaScript transported with Blazor. And so we can use that. Now, if you just combine it with JavaScript, you get a lot of benefits. You recombine freely. So you can, for instance, lazy load Blazor code whenever you want to. You can also introduce fragments from other JavaScript frameworks whenever you want to. So in the end, you get a lot more freedom. On the other hand, we have now problems well, with the mixture of technologies. So we need to know something about JavaScript and C#. And by the way, that's not something that should be new to, because everyone that is aware of Blazor knows that a lot of things are, at the moment at least, only possible via JavaScript interop. And of course, they are encapsulated quite often in libraries. So the number of libraries grows, which means it will be less a problem in the future, but still being aware of this interop mode is quite crucial. And the other problem here is how to publish it correctly, because if we really have independent microfrontends, the tree shaking becomes a problem. And we'll address that also now with our challenges that we go through. And for each challenge, I'll show you how to naively, let's say, tackle it with Blazor. And then in the end, we look at it as a whole. Now, the first challenge is routing, because Blazor is very possessive. It assumes it is the only application running there, and it assumes the way it does routing is the only right way. And that's a problem in the microfrontend scenario. And to illustrate that, I use now the first demo, Blazor routing, and let's kick that off. So let's assume you have an application that should actually contain two things, React and Blazor. So let's have a look how the index HTML looks here. It's the same as you know from the standard template, but there are two things added. So we have here a div with the ID React app. In this div, I will start rendering React, like the app tag here will be used to render Blazor. However, while React is, well, either triggering or not triggering, depending on what the path is, we will see that Blazor actually will always try to grab the full page. Now, the React part comes here via sample React. I will not show the code due to time constraints now, but it's really just a simple React app that shows either we are on foo or we are on bar. So there are two routes basically registered to components, and that's all. Let's start this. And if we are on the standard route on / which we are initially, then we just see the Razor output, which is loading because it's just hard coded there. Now let's see, server starts and loading, great. Now in our Razor menu, I added foo and I added bar, and I don't know if you can see it, it's very small, but if we click on foo, you end up at /foo. So let's do that. And oh, that was strange, right? There was this redirect. So we actually, since Razor didn't find anything to it, it assumes you meant a public link. So it just made the website go to and refresh completely. That's bad because actually React was already there and it could have handled this thing. And we've seen it because React starts really fast. And so React is already displaying and we only see the loading here. And so we're on the foo page of React, but oh, suddenly there is Blazor. And by the way, we are still on the foo page. And all because Razor is very possessive. Right. Yeah, I mean, you notice that we are here on the not found page. So there's a simple way around it too, right? And we can say, well, let's have not found in Razor. Let's just skip it maybe here. Let's not have a layout. When we're in the not found case, let's try this again. And then, of course, in some sense, that's maybe more what we want. But yeah, I mean, foo and bar now works, but what about QXZ or something? That doesn't work. And still, the thing is, we now saw a loading that suddenly disappears. It's not a good experience. And we had a complete, and that's why we saw the loading, we had a complete, re-rendering of the page. And that's also not good. So the two things working side by side here, well, that's not really not really working out. With some tricks maybe, so we can hide the loading, for instance, and all that, but yeah, it's not ideal. So that's challenge number one. How do we deal with that? We'll see. Challenge number two, DOM projection. Now, Blazor is also very possessive regarding where it renders. It actually needs to know from the beginning. So already when Blazor starts, it must know where can I render. You actually define that in your startup. You say, oh, this renders, by the way, to app. You can also give it, I don't know, hash my ID. You can give it the selector where it should render. But again, it wants to have this from the start and it doesn't want to change. But how do you bring now, for instance, your thing that renders inside this app element somewhere else? And you need that for microfrontends. And the answer is you can do what I would call a DOM projection. So it's very simple. React has that out of the box, and it therefore works really flawlessly. In Blazor, I would call that still a hack, but yeah, hopefully they will come up with a solution also for this, an official one. What you can do is you just abuse that Blazor still has a virtual DOM implementation, and that means it also keeps track of your elements and it compares them internally first before doing anything with the document object model. Now, what that means is that if Blazor says, okay, I got this one tree here and only my sub-child changed, then I will also only do the change on the sub-child, and I will not touch the parent or maybe some adjacent children. I will not do that. And that's very important because that means we can transport the DOM representation of the subchild. We can place it somewhere else and Blazor will happily still do that. Now, let me show an example to make that quite illustrative for you. I have here a standard Blazor counter component. And the only thing I did is I placed it here in a special div that I gave the ID projection source. Now I grab this div later on, or more specifically the contents, and I will place it somewhere else. And you will see I can still increment the counter because Blazor doesn't re-render this whole thing. It just renders the part that changed, which is the text content of that paragraph. And that paragraph is from the reference still completely fine. We just moved it somewhere else. And where did we move it? Well, we just move it to somewhere that I defined as a projection target. And the move I trigger here via a JavaScript function that I call project. It should only teach you how that goes in general. You can have that more robust and you actually can do it then from Blazor in the end. But the main idea is that you just grab the source. And this could, by the way, all children. I just pick here because I know it, just one. And then you just bring it to the target and that's it. You would also be required to bring it back to really ensure that this thing is fully working out. And that's then in a real component lifecycle. But for this demo, we don't need to do that. So let's just check it out. So when the web server is started and our Blazor application was loaded, we can just go in here and we can see the counter just works. Well, it's great, right? Now, let's go to our console. Let's use project. So I hope you can see that. And now we got current count 6 down here. And it still just goes up, right? It's now in a completely different element. It's now in the projection target, but it still just reacts to it. Because again, the reference is still the same and it just works via the reference. And therefore we can just move it around in the document object model pretty much as we want to. Again, you must be sure to do the right things here because otherwise, of course, Blazor can crash too if things are unexpected. So you should know how and when to use these projection targets. But that is a nice way how to bring from, let's say, the central flow a component to actually a target where you want to render it. Next challenge, dynamic registration. Now, if you want to lazy load, as we will see later, you somehow need to register also your components, right? So you need to say, oh, I got now a new set of components. Now, for instance, for the router, a new thing of route targets that you want to be able to route to. That's quite important. Even more important, of course, maybe later that you pre-register your routes. To that topic, I'll come in a second. So let's have a look here, what I mean with this dynamic registration. And again, if there are any questions, just shoot. Cool. Now, here we have a little bit more code, unfortunately. But to get the gist of it, we only need to look at this kind of service here that essentially brings two things. One is a list of the currently active components. So these are components that should currently be rendered, and a listener that we know that the list actually changed because yeah, within a Blazor component, Blazor is quite reactive. But outside of it, I mean, we somehow need to couple it. And of course, there are also nicer ways to do it, but just to illustrate fully what goes on here. Okay, now using this service, we also use a special kind of a data type, this active component that essentially comes with, well, 3 parts. The component name, a so-called reference ID, which is like something like the ID of the current instance of this component, and the actual component type. And when we have that, we can actually render this dynamically, and we'll show you that in, I guess here, the placeholder. So, I don't know, this is maybe a bad name, so sorry for the naming. This one takes the activation service as an injection, and then it just walks over all the currently active components. So there are 2 things here. We can register a component, and then we can instantiate it. And yeah, that's pretty much it. An instantiated component will be shown in this list, essentially. And you can think, of course, in variations and when this pattern makes sense here. Here I left out something quite important. I left out arguments, which is not that difficult to place in there because they are just 2 parts, a string and an object. And also this fragment builder that you have there can help you to populate the arguments. But just for simplicity, all the components we throw in there, they are without any parameters that need to be introduced. Now I have also a counter here. It has a variation of the counter. So here I'm using this placeholder, so it will display the currently active components, and I have the click me button, and the click me now performs this next activate, and this does the following. It has a counter internally, and depending on what the value of the counter is, it does certain things. And I did that out of laziness. You can say that's kind of a state machine. I would say it's rather an illustration of something. So in the first, when we click it the first time, this will trigger, and what it will do is it will deactivate a component. Well, there is no component yet, so nothing will happen here. And it will activate a component. Again, nothing registered yet, so nothing will happen in the first click. Then we have the second click, count as 1. What happens there is we register 2 components, a component that I give the name first and a component that I give the name second. And these resolve to the respective Blazor components, and don't worry, they have no specific logic. They're just, displaying I'm first, I'm second. Okay, so far so good. It also does something on this case 1. What it does is it will activate already again first, and this time there is a component registered, so we should see the first component. Then next click, we activate second. Next click, we go back here. This time we remove second, we add first, and so on and so forth. And what you should see that this thing fills up even more, and we will only have firsts because every second will be always removed. So yeah, it's a little bit, but it should show to you that you can dynamically register things that you can dynamically then activate too. And that's quite important, because imagine from a lazy loaded library, you now get this set of components that you need to register somewhat, that you can use it, but you also may want to activate it because suddenly you want to use one of your components, right? Okay, let's click. First click, reset, nothing happens. Second click, first component, second component. Now we remove second component, introduce another first component, and so on and so forth. And so now we're activating more and more of that, and just fills up. And that's pretty much the demo for it. And again, you can now see how that these things are all required and stack up, but and they're all pretty easy to develop actually. Of course, this is just, you know, for demo purposes, and real code would have a lot more and maybe be written also more elegantly that I'm capable of, but you get the idea. Cool. Now, moving on, challenge 4, using these, what I would call shared components. We can also say foreign components, components coming from other frameworks like React. Again, multiple ways to do that. Let me just give you an insight how the React code looks in this example. It's not, let's say, most sophisticated one. What we have here is a simple React application that just exposes to window a function called render React. And that's it. We can then use that from Blazor actually. And it takes 2 arguments, a component name and a container ID. And then actually with the component name, it just selects a component and then instantiates this. So it's pretty much the same code we had in Blazor with the fragment builder. And here we actually select our target, and there we create a new React render tree. We can also have one single render tree and project here, but then we are responsible to also uninject, etc. And I didn't want to do that. And also the React code is not the most interesting one here. What I had is 2 things, a title and a counter component. Here's the counter, for instance, standard React counter. Again, code not so important, but the thing is just a React component. Great. Opening now the Blazor one, and how we leverage this. And again, we want to hide this from actual usage, that you can just say, well, you're more interested in what component to use than what technology this is. And therefore, I created a shared component in Blazor, which I called external. Again, you are for sure more capable of finding a better name. And in this one, I essentially do one thing. I give it an entry point and I assign an ID to it. And this ID is more or less randomly selected. And then I have a parameter, which is the component name. And so whenever this thing first renders, I call render React, and I'm done. I supply these 2 things, like component name and render, and that's it. So my counter now looks as follows. I just have external title, external counter, and I'm done. And maybe the index HTML is also interesting. So here just introduce components.js, which is essentially the resulting script from my React code base that you've just seen. Now let's run it. Loading is always good. Great, now we are here at the counter, and yeah, we can now argue about the design. It's not as beautiful as before, and I just placed button, I didn't place any styles. But the important part is that this thing is coming from React, this thing is coming from React, and it's all defined in my Blazor. And so, of course, if there are these components lying around, then you can do that. Quite straightforward, if it's correctly exposed, as we've seen. Great, we are approaching. So now the biggest challenge, and for this I have the most code, but I will touch it the least because we will see it then when it all comes together. So this is the lazy loading. So Yeah. Where should we start? Because there's a lot of things here. Maybe let's start with some of the changes that have been done. We've seen that the router out of the box requires, well, the assemblies all to be defined. And actually, I don't know why the connector is still in there. I guess I could just remove that because it should stay empty. I don't do anything with it here. And I replaced the standard router from Blazor with this lazy router. Now the lazy router has a couple of capabilities. So it will realize that you actually have, let's say, a lazy navigation behind, and it will do a couple of things. I will, again, not bore you here with all the details, but it's one of the replacements that's necessary in order to work fully. Now, the other thing is Razor has, unfortunately, a design decision that I, also as my background in React, don't understand. They placed the paths of the of the pages inside the pages. Now, that's like anti-pattern number one if you want to have lazy loading pages, because it's a chicken egg problem. You only know that this page exists when you have the page. Now, in React, for instance, it's separated. There's a route component, and there you define, well, your route and where's the component. And then the component can be a lazy component, for instance. What you therefore need to do here, and that's what I did here, is you introduce a new kind of component that I also call lazy. And I now need only to introduce this in already a class, this counter class. And it's just a shallow wrapper to say, I already know the URL, but I don't want to give you the content right now. So the content you need to lazy load. And the content now loads from Blazor lib_a. And yeah, the type that we want to have in there is Blazor lib_a counter. And these are both strings, which means, yeah, you guess it, errors may appear here. And you should try to make sure that, well, this obviously gets typed correctly. Now, the idea already with this lazy loading example here is that there is no project dependency to Blazor lib_a. So if I would open this thing, you see that I only have these references, but there's no Blazor lib_a mentioned here. All right, so let's start that. I just show this demo. It's always a bit of a pain because I need to build the other thing and move it over, but let's see how I can handle it. Now, the first thing that should appear is this whole debugging experience was built again. So not sure if it shouldn't have preserved anything. So the first time we use this, we actually should get an error. Well, actually it already loaded. Great. So it didn't override. Wonderful. So it works just out of the box. One of the pleasant experiences. Great. So we loaded now Blazor lib_a and the debug files too. And here it is. It's fully functional. And we just loaded it when we first used it. Again, let's load it. We get all these files. But if you look there, there is no Blazor lib_a loaded. And we can navigate to fetch data. I mean, now we fetched the weather JSON, but nothing happened, right? And again, if I now click on counter, it took a while and then it was there because we first had to load the library, which is in this case rather small, but you get the idea, right? And so you can do that. It loads it. It also comes with then the debugging files with your symbols, and then it just works. But it's a lot more work to do that because you need via the fetch call to do that, to really load the assembly, and of course to wire it up correctly. And that doesn't even include all the work that's necessary for the what I would call reverse tree shaking. So by default, what Blazor does to actually crunch it down to 1.6 megabyte is it will remove things that are not used by you. The most things that are removed are actually full libraries, and that's actually very easy because if you see that these are required again, you just bring them in. And actually the things that can be moved out of the libraries, that's also not so much, and they are quite exotic pieces. So in, let's say, 99 or 95 of 100 cases, you don't need to do anything. But in the remaining 5 cases, it's really something that now is missing from, for instance, your reflection capabilities or some other capabilities of, well, a core library, most importantly MS Core Lib actually, and that was moved out. And then the question is how to bring it back in. And of course, there's a solution to that, and that's satellite assembly. So you need to pretty much look what's the diff, and then make a new library that's a satellite to the original one that just includes the stripped out code, and then it just works. But that's, of course, some additional tooling effort, and yeah, that it works, let's say, in an out-of-the-box compilation step, that's not trivial, to say the least. But that's effort you would need to do to make this reliably working. And that brings me to the grand finale here, the reference implementation. And as George already mentioned, there's a framework for modular distributed microfrontends, and we called it Piral. Now, the origins of Piral, they're different. So it goes back, well, we started with microfrontends like around about 4 years ago. And like 2 years ago, we saw a pattern emerging. I think that for most of our customers worked. And we thought, let's make an open source framework out of this. Let's base it also on React. That's why we've seen React code. Because we think that there should be a strong foundation for this, and a foundation where you can just build your applications already and not wonder about what technology to use. But you can still throw in whatever technologies you want. There are a couple of principles. I just want to go over that because also for time reasons, we want to ensure first there's development experience, so no long setup. We want to make it possible just via templates to just come here and say, I want to scaffold a new microfrontend based on your needs. It should just be easily possible. It should ensure that really a distributed development is possible. So independent teams autonomously can also deploy, develop, whatever. As I said, mainly targeted regarding towards React, but also friendly towards other frameworks. So if you have an existing framework, you can easily bring it in. So this is great, for instance, for migration paths, or as we see now with Blazor, for specific parts, you say, now that makes sense that this thing is in Blazor because either you already have the resources or you already have, let's say, the code available in this language. And yeah, it should be possible to support already backend services with some convenience, for instance, loading data lazily, etc., and having just a very well-established flow. Just a brief look at the high-level architecture. How do we make that possible? I mean, it's all based on this modulet that we introduced with the application shell, and then all the microfrontends in form of modules. Towards the end user, that looks as follows. You have your application shell that we call Piral instance. That may be sitting on a static storage like Azure Blob Storage. Could also, of course, be, as announced yesterday, on the static website feature from Azure. Perfect fit here. And then what you also need to bring in are these microfrontends, and we call them pilots. So Piral and pilots. And the pilots, they can also sit now on a blob storage, for instance. Actually, they are delivered usually from a blob storage, from a CDN, to be really fast. You usually interact with the so-called feed service, which stores all these pilots via the Piral CLI. So that feed service has a standard REST API endpoint, so you can just publish via REST well, control it. You can write your own feed service, or there's also publicly available one. Right, as said, Piral instance WW, and then if you look at the reference implementation, but again, you can come up with your own thing. We just use a standard load balancing with DNS. We have the feed service and everything running a Kubernetes cluster, and use Azure CDN for all the modules. And that's about it. All the standard assets are therefore stored in a blob storage. And now one of your pilots may be a Blazor pilot, or actually multiple. And let's look how that looks like in with this Piral as your engine. Now, first we need to have a look at the application shell. Let's do this follows. Let's actually go to, let's bear with me. I will change the font size in a second. Not really prepared, but we can do that. Alrighty, Great, where am I? Looks good. Let's start VS Code. And let's start this thing, and I will walk over this code in a second when it's VS Code starts the communication with the WSL. And in the meantime, happy to answer questions. Is there any? Cool. So we also have an index HTML here. As we know from Blazor, right? You always need an HTML file. That's the thing consumed by the browser. And here we just set our title and we set our entry point, and that's about it. Now this thing, it can look completely different, and you can also write it in a more React manner, but we can also use abstractions like, for instance, render instance, and that just will do pretty much everything we want to in the end. And what we supply here as arguments are just a layout, some error handling, and maybe additional APIs. And in this case, we want to connect Blazor to it, so we actually add a Blazor API extension for it, and we will see that will allow us to actually write pilots with Blazor very easily. And then we need to say where to get these pilots from. So we can do that from whatever we want to, right? So we can use GraphQL. They can already be embedded in the document. Or here we say, let's fetch our existing pilots from this URL. And that actually goes to the official feed service. Actually, it just goes to an empty feed. But yeah, we could bring in whatever feed you want to. And we will see that in a second. Right, so that being said, that's what we get. It's an empty shell pretty much. So there's just hello Munich. I added that, and we already have a not found page with this custom error, and that's it. It's a single page application, but it already allows us to enter some feeds. So for instance, we could say, let's just consume the sample feed, just there. And oops, so, and if we do that, I mean, it doesn't look nice because that app shell was of course not designed for it. But we see that already something loads, and actually some parts of that look like they are intended to, and some pilots even come up with their pages. Like for instance, here there's a page and you can play Mario 5. That's great, right? Or I don't know, you can play a round of this floppy volley kind of thing here, which is quite nice because they're all coming from different pilots, and you can already just consume that and it will work. Well, up to, of course, maybe there are shared libraries that you don't have, or, you know, design-wise, it doesn't fit. But again, that is just how you consume a feed, and yeah. Great. So much of that. So that's pretty much what you can do developing an application shell. Now the rest would just be React, but what you can do with it is that you can build it and deploy it via standard NPM mechanisms. Actually, that was done beforehand. I don't want to trigger that again. And what you get out there is two different folders. One is called release. So that's a folder you would actually then publish via FTP, or I don't know, a blob storage copy to your target. And there you go, there's all your files. And another thing is the emulator that you would consume for developing a pilot. So why do you need this emulator? Well, when you create your micro frontend, you want to see the application shell, right? Because I mean, that gives you the basic design, like in this case, the header bar or the error handling, and of course the shared dependencies. And you want to have that, and that's why you create this kind of emulator. Cool. So now going therefore one step further and then looking how the development with the pilot goes, we will see that actually it looks pretty much similar, but there are some differences because in this case you want to write Blazor, right? Maybe let's start this thing already. All right. Okay, let's refresh. Okay, so here we see something like welcome to Piral. Let's have a look where we can find this here. So So essentially, we don't have many files here. It's just a standard Node project. And yeah, we also see there is also a C# project here. But we have this index TSX. And essentially, a pilot is nothing more than just a library. Yes, it can have more things. It can come with assets. But in a nutshell, it's just a JavaScript library. And this library is expected to export one thing and can export other things too, but one thing is crucial, it's a setup function. This setup function then takes our API towards the application shell, and in this API we have all the options that are currently made available from the application shell. So we can here do all kinds of crazy things with data or registering something, I don't know, translation is apparently part of that. And we can extend this thing. So we extended it already to bring in from Blazor and define Blazor references. We did that with just a plugin that exists for Piral, and that plugin pretty much brought in all these capabilities. Now, what we do here is a couple of things. Since it's Blazor, we need to define where the DLLs sit, and that is done in this one line. We just say define Blazor references, and then we just use generated code that actually generates the right references for us. We can also be explicit here, but let's just say this line is fine. And then we can define certain things, like for instance, here we define this tile, and we can actually say, welcome to Piral, Munich. And now the screen here shows welcome to Piral, Munich, and I can just, play around with this, and it just loads and does the right things for me. Okay, we also define here two more things, a menu entry and a page. So for these two, we don't use this kind of syntax, which is just React, you may have noticed. We actually say something special. We say app from Blazor, and then we give it a strange name. And here the same with a definition of the URL. So we say /counter goes to, well, from Blazor counter. And this is where we now move into the Blazor space. So essentially, we only use now this one file where the setup function is to actually define where our different Blazor parts are. And that's quite important because this one file you can think of is loaded initially when your application starts, and it can now lazily define what other things to register. And when these things are actually required, you will actually use them. And so you get lazy loading out of the box, and there is nothing that is special to any kind of router, etc. Maybe let's have a look there for as it behaves. You just go to Blazor counter, and yeah, there's our standard counter, right? So pretty straightforward. Cool. So with that being said, let's have. I will never find the right one. Let's. Oops. Let's go into the right directory and let's just open the solution. And let's have a look there. So this is also, let's say, more or less a standard Blazor application with Target WebAssembly. But there are a couple of interesting things here. Now, the first thing is, at the moment, to make this kind of convenient, I perform a kind of, let's say, hackish way of regenerating or triggering that something changed in our targets. But that left aside, I include the Piral Blazor utilities. So this is just a standard NuGet package to deliver some functionality like an anchor tag that just uses the right router, for instance. In the future, we will also use, I guess, the nav item because we deactivated it anyway, the standard location. But yeah, so for the moment, we just use our own tag. Also, it comes with some other things, like, for instance, the capability of using React components out of the box. All right, so it also comes with this expose pilot attribute, and that's the meat that actually gives these names, right? So here you see this name counter, and you saw the name beforehand. And for instance, for the counter menu, you see counter menu here as expose pilot. Now, all the components that are exposed, well, you can use them in this setup method. So for instance, if I want to change Blazor counter to just Blazor, then I do that. Let's just rebuild here. And well, let's see. So, oh, okay, didn't do anything, but there it just took a little bit of a time. You can do it again. Maybe let's call it my counter. It just refreshes again, and you just get the current view of it. Again, no hands now. My counter was just a little bit slow last time. And yeah, so that's the basic idea, that you can just develop that as if it would be a standard Blazor application. You even have your entry points, even though main shouldn't do anything here, but you can also configure your services and make a dependency injection as you're used to. And in the end, that just works together. Right, and that's now how you would define it. So it's split already into two parts, and it's already lazy loading. And let's see that maybe as a last thing here, it's lazy loading. Let's make it a little bit larger. Right, so first is, it takes a little bit of a time, then this is displayed, but yeah, at the moment the lazy loading, you could say, doesn't make so much sense because menu items are always displayed. So let's therefore change this, and let's remove the menu item, and let's maybe have the tile in React go to the counter component, right? Right, so let's say, let's remove this, and maybe, oh, I don't know, let's use just link. And let's say to counter. And let's type it out here, React. I hope I didn't do any mistake here. It's already blue. So let's start fresh again to see that this library is not loaded. Actually, you can see there's nothing loaded of Blazor yet. So the startup is really fast, and there's not much transferred, right? 2.1 megabytes transferred. Yeah, that's just because they are, of course, quite heavy in development mode, all these things. But yeah, nothing more. Now we click on it, it's empty. Now it's loaded, and it loaded all these things, right? So it just now loads when these things are demanded. That makes it so fast, because you cannot grow your application. Only when these things now need to be used, they actually come in, and well, then they are just there, right? So subsequent requests are then super fast, as you can see. All right, great. Just a recap on the application shell development. What did we do here? Especially for the pilot. So what we create is this Piral instance. You can then share that via NPM, for instance, can be a private NPM feed, of course. And you also use already all the resources from NPM, like Piral or the Piral CLI that makes building, etc., very convenient. Then you also reference Piral Blazor, which is the plugin, and that all comes together in your Piral instance. Now for the pilot, you have now this type-only reference, essentially run it in debug mode in the application shell. And then you just bring in other dependencies for NPM whenever you need them or not, right? In this case, we don't have any, so the pilot is really small. And finally, the Blazor pilot, well, that now comes with the other dependencies from NuGet, but it references the Piral Blazor utilities. And that's a rather complicated picture, I know, but in essence, all you need to know is it enables that you just write now certain functionalities using Blazor, just using C# code, and the glue is now sitting in JavaScript. We thought about also bringing that to C#, but since the API is really flexible, and I mean, flexible means that it's not one defined set. You can extend that whatever you want from your application shell. We cannot bring it with type safety, etc., to C# in a very easy manner. So it would not be type safe, and then choosing TypeScript to do that is much, much better. And we will also in the future add that your exposed components are already marked correctly, that even this thing is actually already fully type safe. All right, I already mentioned number 2 was the contribution areas. If you haven't seen them, I will illustrate them first off, and that's now sorted by let's say effort. Star Piral, make sure that everyone knows about Piral. It's awesome, and we love it, and we would love discussions there, contributions there, and I would say we already have a neat little community growing there. It's quite nice to be part of it. We have a lot of fun on our chats on Gitter and also in one-to-ones with the teams. Debugging, as you've seen, I've always released that directly. Yes, debugging is not so difficult actually to get in, because at the end it's just a WebSocket connection, and you can do pretty much the same as what Blazor WebAssembly does out of the box. With your pilot, it's just a matter of wiring it up, and that's actually, well, it's not super simple, but it's also not super difficult. Further convenience, so that of course starts with debugging, but it includes a lot more things, and we have already seen them. For instance, type safety for your exposed pilot components, so for your exposed Blazor components and pilots, etc. So all these convenience topics, they need to be tackled to make this really fun to develop. Templating, we started with a simple template, but it's nowhere near where it should be. And there are certainly guys out there who know a lot more about Visual Studio templating and how to make that work correctly, and maybe even a Visual Studio extension and all that. And that would be awesome. And the most important part is, and we started already with a proof of concept and implementing that. But again, having it all with the full circle in debugging, convenience, and also in templating, the reverse reshaking, that's also an area where contributions would be appreciated. And in conclusion, so we started with the microfrontend architecture as an example, went on then to looking at how well we can do it just using out-of-the-box measures to grow in Blazor. We've seen it's possible, but it has limitations. So the architecture for distributed Blazor components, and then we went on and we've seen the different areas with code examples, and we had a look at one realization of that with Piral. Again, it's just a reference implementation. You can roll out your own. You can take these pieces that I've shown and bunch them together as you want to. And I hope that I could at least transport a little bit of why that is useful, why it makes sense, and what the current state of microfrontends with Blazor is in this session. And I'm now happy to take questions if there are any. And again, I will distribute the slides and all the material that's gathered there. Thanks.
Thank you, Florian, for this very interesting presentation. It was really lightning, and the beginning about how, for example, what are the difference of a monolithic and the micro front-end approach, and how the problems that the microservices architecture somehow not exactly the same, of course, but apply to front-ends. Same concept there, different implementations, let's say. So very interesting, these things for me. One very interesting thing was that how different pilots communicate with each other. So pilots from different technology, underlying technology, to Blazor pilots. How do you change one thing in one pilot, and that affects somehow triggers a change in another pilot? That would be an interesting thing. If you have any more details there, that would be very interesting for me. And another thing, do you have any quick start advices for someone that just want to start with Piral? That would be very nice.
Yeah, so regarding the, let's say, pilot interaction, so that's actually one of the strengths of Piral, is that you can have all these interactions between the pilots. So we have different ways of, let's say, communication between them. Of course, they are all loosely based, which makes it both difficult and powerful. So for instance, we can, of course, communicate via events. We can also communicate via data, and we can even communicate via what we've seen also in the talk slightly via these extensions. So the idea there was that you actually can provide a component from one micro frontend that just, you know, has, let's say, a common name, and another micro frontend can just pick it up via this name. Now, the things that make it complicated is, first of all, what is the set of parameters? Does this component require parameters? And the other thing, of course, is design-wise, how does it make sense? Because maybe this one thing says, well, here should be a component that goes inline, but the other component says, well, I am a table, I come as a div, I'm a block element or whatever. And so there are these things that make it, let's say, powerful, but also partially not so easy to work with. But we've always wanted to have it loosely coupled, because once you actually say, I want that component exactly from this pilot, then you're doomed, because in our view of this world, not all components are ensured, not all pilots are ensured to be delivered to the end user, right? If you're sure that one bundle always goes to the end user, then a question is, why aren't they always in the same pilot? And of course, if you would say, well, it's a different domain, then you could also argue, well, if it's a different domain, why should things from the one domain influence the other? Of course, there can be these reasons. But in the end, I mean, this how you break it down is a really complicated approach that's not specific now to Pirrot, but in general, I mean, microservice is the same thing, right? You can always debate, is this the boundary of the microservice? Is it larger? Is it smaller? Should they now share something? Now I have this complicated pattern. What about transactions? It's always these things, and they come back here too, right? Now, just on a different level, because we are now sitting here on the UI. So what Pirrot brings, therefore, is it really enables you with this loose kind of thinking. So you can just reference, say, I have this what we call extension slot. We name it, I don't know, like machine overview. And if someone has a good component that fits to machine overview, you can just place it in there. But if no one offers it, it also will not crash or anything. And we also make sure if you pass in wrong parameters and that nothing renders there, and things will just stay always in a let's say, very controlled fashion. So that's what Pirrot gives you on top. It gives you these ways of communication. Now, that being said, there can, of course, still be things where pilots collide. It shouldn't be the case, but can be, of course. Now, that now is more or less in the space then of there is still alignment between teams and of course, domains, how they are split, conventions that need to be built up. So Pilot is not a solution that I would say does it all for you. For instance, if you say we want to introduce third-party developers that we don't know of and they can just freely publish, it's definitely not the right approach, because we don't do anything there to guard you from, let's say, someone, Russian mobsters brought in keylogger. It can always happen. Nothing against Russia here, by the way. Just, you know, it's a standard joke, I guess, in the IT community. Therefore, I wouldn't do that, right? So, I mean, there are still means to introduce that via separated feeds, via user opt-ins, and then, of course, in the backend, via static analysis of the code that was brought in. But Pirrot itself tries just to, you know, have, for instance, a safety net that your application will never crash from some pilots. So you can never bring down the whole application if just one component or one pilot crashes. It will always work, and it will ensure that whatever configuration you have, it may not make sense to the end user, but it will still work as an application, which is one of the reasons why you don't pick from one pilot and say that's the component. Even though, of course, you could say via convention, I name all my extensions like the name of the pilot / component or something, and then, of course, your extension slot is. But that's then up to the architect of that solution to decide what are good conventions and how these slots are named. Regarding the second question, getting into Pirrot as a solution. So there are different ways. So if we think in terms of the talk with Blazor, right? At the moment, it's, I would say, not very beginner friendly. And there are several reasons for that. The first reason is, in general, the standard approach towards Pirrot is that you start with the application shell. That, of course, is maybe for someone who wants to get into micro frontends or who just wants to play around the first blocker, because why should I first create now an application shell if all I want to have is this micro frontend, right? And then, of course, then this thing is written in React. Of course, you can bring in other technologies, but let's say it's written in React, so it may not be your ideal approach. We also, in the meantime, brought out something else that we call siteless, which is essentially Pirrot under the hood, but the app shell is empty and you already start with pilots, and it's an easier way. It's not yet there for Blazor. Potentially we'll release a Blazor only version of siteless, and then all you would do is just write Blazor code. But if we take this as a basis and you already have an app shell, at the moment what we are lacking, and that's also what was on the contribution list, is proper template that all you can do is, you just install this thing, and then everything, including debugging, just works, and you don't have to do any additional work. You don't have to read documentation besides, install the template and run the template and then, develop. That's certainly something we need to improve on. We are currently ramping that up, and in the next, let's say, 1.5 months, this will certainly be up to speed. Yeah, that's at the moment what I can say regarding getting into with Blazor. Getting in general into Piral, I guess that's a well-established path. We have a whole video series out there also, and a lot of material on the docs.piral.io page. And so I guess that is for people who are into the front-end development rather accessible. But still, micro frontends are, I wouldn't be, if I wouldn't know anything about front-end development, it would not be, now I'm doing micro frontends. It's the same as a backend, right? So if you don't know anything, I've never written a service, then starting already with a microservice backend, maybe you should first learn the basics.
Yeah. Very interesting. So we could say that a nice solution and a nice approach architectural-wise would be that the micro frontend could somehow be connected with a microservice on the backend, and thus bringing a microservice down will not bring the entire application down. It will just bring a small part. And that is why it's nice that they are isolated and decoupled, let's say, from one another. Yeah. Very interesting. Now, I know that this might not be the case for today, but what about non-JavaScript environments? Is this, because as far as I've seen, it's heavily working with JavaScript. Is there a solution there?
So Blazor already requires JavaScript, so we would need to leave out, let's say, Blazor and just come back to bare micro frontends. And yes, there are solutions out there. As mentioned, these implementation patterns, there are the server-side composition patterns. So one thing is to just use a reverse proxy, like for instance Nginx or Varnish, which is even more powerful, and to use things like ESI, which is short for edge side includes. So there you can define the fragments that you put in there, and these fragments can even define where the resources sit. So essentially you're just now writing bare HTML files, or again, render them, from PHP or ASP.NET MVC or whatever you want to render them, right? And then they come all together. So they're also on their own microservices, but then they come together in this reverse proxy. So they're not seen then from the end user as individual pieces that, for instance, come together as JavaScript or whatever, but yeah, it already receives this as one thing, and the reverse proxy does all the work. So that's the most standard pattern there. There are also patterns involving web components. Again, that's then client side stitching it first, but you can even use these web components to already make resolve them, let's say, on the server side. Then it's again some logic. What makes Piral there great is, since it's React, I mean, let's leave out again Blazor, the Blazor part. If you just have the React part, that also enables server-side rendering. So with Piral, in the basic mode, you can just also server-side render if you want to, if you place it in Express or Node.js in general, and serve it, you can do that, and it will work. But usually it's not worth the effort, because then you have to ensure that instead of using cheap static site, some storage, I don't know, can be even Dropbox, can be Azure Blob Storage, you now need a service, and that needs to scale. And rendering React is not so cheap as you might think. So yeah, you need to have good caching there, you need to be aware of all the things, and plus your development teams need to be aware of things. So they cannot use just in a standard React component in the rendering flow, just window or something, right? They need to check is window there, because if not, then I'm in the server side mode. And all their components that they write, they need to be prepared that they also can be rendered or hydrated from the server side, right? And that is quite often a challenge. And again, Piral is, the main objective is to be in this tool space for portal applications, for instance. And there you usually don't need the server side, but if you really want to have it, you can introduce it. But we, well, have it in our tutorials quite in the back, because we think it's,
yeah,
you have very specific needs if you go there. So it's really, we want to start with the most generic use cases, and then say, if you want to have that, that's, by the way, how you do it. It is usual. That's why there are even dedicated React-based frameworks for that already come then with server-side rendering and everything that, of course, you can do also yourself, but they also always follow best practices, etc. It's like Next.js, etc. And these are huge things usually, and they try to bring in all the best practices and caching and whatnot, and yeah,
yep,
things like that.
yep. Okay. Anyone else? Any question? I just have one last one. If no one else has any question, I just went quickly into Piral.io, and I noticed that you have Piral and Piral Core. And is there any difference, and how do you use them?
Yeah, so it's a little bit of a layered approach. So Piral is one thing does all. So it's more or less a framework. You get it in, it comes already with defined dependencies like React, React DOM, it's all defined for you. Essentially, it can be your own dependency. As we've seen in the standard template, it even comes with polyfills for you. You can override them, of course, but it comes with all these things. It also comes with already acquired what we call the standard set of APIs. Things like translation is already in there. And so it may be a good choice if you start from scratch. If you say, greenfield, what do? I want to have a thing that I don't waste a lot of time and just work. You just start with Piral and you're done. So Piral core is, you have an existing React application, everything's set, and you say, now this Piral thing is nice with the pilots. I want to have additional pages and maybe additional things for, I don't know, additional menu entries and other points that I define in there. You just reference Piral core. It has no strong reference to React or so. You can use your own version, and then you're done. You just drop in a component, a Piral component, where you specify all the options, and yeah, that's how you use this. So, and there is even Piral base, which actually doesn't require React at all. So Piral base only has all these things to talk to the feed service and to know the definition of a pilot and bring that in. So if you, let's say the architecture of Piral is nice, but I don't want to reinvent everything, I want to reuse the Piral CLI, then you also can start with Piral base, which is really a vanilla JavaScript piece that just allows you this fragment loading and everything. And yeah, certain things, all the plugin space is always has a peer dependency on Piral core. So many of them will not work, others should, but yeah, many of them are based on Piral core, because the, let's say, glue component for enabling third-party components, that's also a React component, and therefore Piral core. But Piral base gives you, I guess, a nice starting point. So we had one customer who actually had a large code base in Angular, and they said, oh, we like this Piral stuff. What can we do? And we said, let's just introduce Piral base. That's how we introduced it, and they then built their microfrontend solution in Angular using Piral base. And
Nice.
it's they can use all the tooling and everything. The feeds all works, but yeah, that's why we have this layered approach. And it's in the slide deck. We have that also in the appendix there defined when I upload it.
Nice, nice, very interesting. Especially if you have a solution ready-made and you just want to get into this world, then the Piral base might be the best approach. And then maybe a future solution, when you start from scratch, you can start using Piral as a whole. Nice, very interesting. I think I'm done with the questions. Anyone else? Because if not, I think No. No. One of the strange things of this remote thing that we are doing and virtual everything is that you are not actually know if indeed everything is okay. So it's quite a different experience. It's all the meetups and talks I've done. This was a major problem. Interaction is quite significant. Anyway, yeah. I think we are done. Thank you very much for this talk, for this presentation. It was really, really interesting. I hope we can have you again sometime in the future for another talk. And I see a hand, or I see a yeah, thumbs up. Thank you for that, Vanista.
That's cool.
Yeah, very interesting. Thank you very much. I hope we will have you again sometime in the future. Hopefully it will not be far away in the future, and hopefully the next meetup will be live. Let's see how things go. Up
Maybe in the
until then.
outside. Beer
Yeah,
garden,
that would be a nice idea, you know, under the trees or something. Yeah, that would be nice. Yeah, sure.
Summer, it is nice now in Munich, so maybe it's a good opportunity.
Yeah, you never know. That's a nice idea. So cool. Thank you, everybody.
Thanks, everyone, for having me.
Have a nice evening and talk soon.
Same here. Bye, guys.
Bye.
Bye.